Hi, good morning. My name is Madalyn and today I'll be talking about chemical weathering, and I did my project at Mission San Jose. So I included a little photo where it's at on the map of San Antonio, and as you can see, it's part of like the south part of San Antonio and not too far from the downtown area. So a little background on this is that in the 1700s, the Franciscan missionaries established 6 missions along the San Antonio River. And there are 5 missions that survive and 4 are active parishes and are part of the San Antonio Missions National Historical Park. Also, Mission San Jose was considered the strongest and most beautiful of the missions. And today the restored outer walls show how the missions could be defended from attack. So here we have a photo of how part of it looked at the time, and it shows how colorful and nice it looked, and you may be wondering if it looks the same, and well, the answer is no, and due to or mostly to chemical weathering. Okay, here we have a photo I took from Mission San Jose, and as you can see here, it doesn't look the same. Right here we can see how the limestone used for this structure was corroded and wasted away. As many years go by, you can see during that time chemical weathering took place. We can see that chemical weathering is present because we know that chemical weathering helps reduce a rock to smaller pieces through chemical reactions, and the products of chemical weathering are different from the original rock material. So you wouldn't be able to put the rock back together to its original form, even if you had all its chemically weathered pieces at hand. And the types of chemical weathering that we learned in class were oxidation and carbonic acid action, and they are both 2 common processes that occur with chemical weathering. And oxidation usually is mostly seen with iron because it creates rust, while here we're going to probably see carbonic acid or acidic weathering, which is when carbon dioxide dissolves in water and it forms carbonic acid. So the carbon dioxide gets the gas that gets in liquid water the same way that oxygen that fish breathe gets into water. So the carbonic acid can help dissolve the rocks, and in this case I guess the limestone rock is very susceptible to carbonic acid action when acidified water like rainwater is in contact with it. So the limestone is easily dissolved or broken down by the acid, and I guess over the hundreds of years it just keeps going and going. Going and going in the way that the weathering just continues, and that's why we see or the lack of how it used to look until how it looks now. So here we also see how chemical weathering has occurred or taken place around these arches of the building. It's called the convento area, and I zoomed in a little closer. You can see the rock wearing away and really how the chemical weathering takes place, and even if you did have the pieces to put back, you wouldn't be able to. So here's another photo of the area where you can see chemical weathering happening and how it's been corroding and all the sediments that just basically eroded or weathered away throughout all those hundreds of years. And this looks like it was the oven area. Right here you can see I guess it all corroded, but what would look like an oven area. And this little wall right here is the wall that they used for defense, from attacks and stuff. And also right here I put photos of all the sediments in the ground where you can see just basically how I guess where physical weathering probably took place. And here I just included a photo that I took in New Orleans of this graveyard or tombstone or whatever you'd like to call it, but it just also is another representation of chemical weathering and how this limestone has worn away and corroded due to the carbon dioxide that dissolved in water that formed the carbonic acid that made it go through acidic chemical weathering. And thank you so much.